Are you gonna be able to see from there if I put this thing? Alright, here we go. There's some tricks. It says check solution, so I think one of these don't work. Maybe we're wrong. Did one of them not work here? I got a 0. Okay. Okay, here we go. Boom, square it, boom, square it. So if this was a little 3 in the index, I would have done a power of 3. The opposite of a square root is a x squared of 2, so I square both sides. And that's terrific. Cancels that out, and it frees up 10x plus 9. Over here, however, I have x plus 3 squared. Most people, well-intentioned, very hardworking people, would accidentally write x squared plus 9 here. But this has to be side by side written out, and you have to distribute the x through and the 3 through. So that's where you have to do a whole foiling process, and you end up with x squared plus 3x plus 3x plus 9, x squared plus 6x plus 9. Okay, so now we have a quadratic. Whenever you have a quadratic here, we're going to set one side equal to 0. So linear equations, that's not necessary. For quad, set to 0. So I'm going to minus the 9 from here, set it up over here, and they just happen to cancel. I get 10x equals x squared plus 6x minus the 10x, and I get 0 is x squared minus 4x. Because the 9's canceled, so. How'd it go, Carson? Same work so far? Oh, you don't know. You just have a final answer. You don't have any more. What's your answer? You two answers. I think one of them doesn't work. Yeah, I think one of them doesn't work. All right, so this really stumped first period. First period could not figure out how to factor this thing. There is a method of factoring when there is no C value. What will we do? What do we do? How do we factor x squared minus 4x? What's the method? There's one thing you should always do before you try any other method of factoring. What's that one thing? GCF. Take a greatest common factor out. This greatest common factor is x. So when I only have two terms, a lot of times I look for maybe can I pull an x out. So this is x minus 4. That's factored by GCF. Make them both equal 0 and solve. Sure, one of these things doesn't work.
Yeah, it's kind of like complicated. You can't make it seem like you're assuming. No. Yeah, they're like ugly. They're like dark. Like you roll and tells you what they put blocks in certain places in there, and then you gotta put all the blocks in the way down. Yeah, like that. Hat, dog, cheese. Cheese, cat, something, whatever it's called. Or chess. I barely know how to play chess, but I'm
They both work? They both work together? Okay. Alright, I'm gonna add 4, and I get 2 answers. Possibly x is 0, possibly x is 4. I'm gonna check these because a lot of times when you have, oh, they do both work. Just saw it. Oh, when you plug them back in, it'll come out true. Square root of 9 is 3, and the square root of 49 is 7. Anyway, Kevin and Gabe, how come you guys got alternate answers? Did you figure out why? You didn't get 4. Why did you get 0? You just ignored the GCF? Okay. And how did you not get the 0?
Yeah, did you know that the goal that we got was so serious? What did you figure out?
Alright, any questions on number 1? Let's do number 2. Alright. Number 2 is messed up like this because of the minus sign. I'm actually gonna move a whole radical to the other side of the line. And that's okay, you're allowed to do that. I'm gonna add the cube root of 8x plus 1 to the other side. And that's gonna give me the cube root of 2x minus 5 equals the cube root of 8x plus 1. Now, since we have an index of 3, we want to cancel out. We're going to do exponent 3 on both sides. Good morning. Alright, so the exponent of 3 cancels the index out. Oop, oop. And we have 2x minus 5 equals 8x plus 1. And who's finished it? Raise your hand if you've already finished it. Alright, so I'm going to pause and let you guys finish it.
How does this one more water out of the like this one runs out like there's no like it's out like this. You usually do it. Yes, what I do first is I wouldn't take it in grams. That's the reason that you take the smaller x value and you subtract it and it's got more. And I didn't leave it in there and just put on the 8x. It just happened. I don't know, probably twice. Yeah, but like using numbers on the side of the X and then that instead. Why don't you actually get your motion on?
What's the answer, Jonathan? Subtract 2x, subtract 2x, negative 5, 6x plus 1, minus 1, minus 1, negative 6, 6x, negative 1 and 12x. Anybody else get negative 1? Nice, good job. All right, let's check the assignment from yesterday. So when you're ready, go to page 477. Yeah, you had to do the evens I did in class. We didn't do finish them. Hopefully you already checked your odd answers, but here they are if you didn't. Let's say you go out and you get a career in accounting or anything. Nobody is going to take answers without justifying what the work. It's a process we show it. That's all. It's not offensive. It's not personal. It's just a process.
What are the credits?
You know, rebellious. No, you don't get credit without showing work.
Yes, you asked me mid class yesterday, what question are you at? I told you I was at 13. I got to work from my other, I got to work from my other.
How many problems did you show work on? You're not arguing about everything.
Because you're not gonna not give me credit just because there's no work when these are simple answers that I can do on my calculator.
How many people will just write exercises?
I don't even have full math down.
I'm saying, out of 200, if I just took numbers here, how many people would just write the numbers from the text message and get something else? Show your work. Doing the work helps you remember it longer. There's multiple reasons to justify showing work. It's not that serious. It's like the same process for everybody. Show work. So offended when someone wants to hold you accountable like everybody else.
Stop holding me accountable.
I am holding you accountable just like everybody else. You want special treatment.
I don't want special treatment when I did the work.
You gotta show it. There's no proof.
Where is Tyler? Oh, can you go over number 18 as well?
Maybe.
No, but I'm saying, can you go over cutting numbers?
Okay, I need to go through at least one of these word problems. 12 is just as good. We got our elephant word problem. The shoulder.
Did you not say in class yesterday we have to do all the even colors?
I actually said just the opposite of that.
You said evens.
I said evens in class, odds for homework.
There's no way, because whenever I was in class, I said, do we just have to do the evens? Just finish the evens. And you said yes.
I must have misheard you.
I didn't do odds, so.
It's okay. You have all your work shown for all those problems. It's okay, Libby. Alright, the shoulder height in centimeters of a male Asian elephant can be modeled by h equals 62.5 cubic root of t plus 75.8. T is the age in years of elephant. Determine the age of an elephant with a shoulder height of 250. So this is h is 250. So we're gonna put 250 right here. Yes, Vantress. You had your backpack up and your phone out. I said, Vantress, are you working on the work? And you said, yes, I'm doing it. Okay? That's the only conversation we had.
So I'm doing the work. If I'm doing the work,
Vantress, you know how many people I look at with their phone out saying they're doing their work? Like every single person. I don't know what you're doing. Put your phone away, put your backpack off your table, and show your work, and you'll get credit like everybody else. This is silly. You sound silly. Like, how am I gonna give you credit for just writing 10 numbers down? Half those answers are in the back of the book. The process is what's important.
You want me to come up to the board and show you how to do every single one of these problems? I will.
No, if you want credit on an assignment and show your work, that's what I want.
Okay, I'm gonna come show you work. I'll come show you work.
Listen, I am very fair in that I stay available after school, so you can come in and get full credit on any assignment you don't get credit for. Do you know how many math teachers do that? Not a lot. Not a lot. I'm pretty sure I might be the only one at this school. Just come in after school and get full credit on anything you want to. That's so fair. That's so fair.
Right answers on it.
No, there's not a single high school math teacher who gives you credit for not showing work. Who? I'll go talk to him.
Go ahead, show them these answers.
Please, who? Put a name out there.
Huh?
Put a name out
I can go to Miss Kruger.
Miss Kruger's gonna give you credit without showing work?
Yes, if you
No,
have the
she
right
won't.
answer, she knows you've been working.
Not on an algebra 2 question. Absolutely not. You're gonna walk over there and talk to Miss Kruger. She would not give you credit for that.
For a self-explanatory question, yes, she would.
No, she wouldn't.
Something you can easily do in your calculator.
No, she wouldn't.
Eventually, you just got one more intelligence.
No, Miss Kruger does not play. You should not have called out Miss Kruger. That's one I want.
Right there, show it to her. And she still don't give me credit. She don't know about that.
We do our homework in class anyway. So, yeah, she would do it with us. We'd like have full credit if we did it in class. But if we did it.
It's a lot.
It's like someone one she knew who was
Yeah, I don't even look at it.
Alright, so I'm going to subtract the 75 and then divide. I end up with 2 does it say right around? 787 is the cube root of t. And then I have to cancel a cube root, so I raise both sides to a power of 3. Man, I just love to argue. I really do. Alright, and then we get 21.652 equals T. So the age of an elephant, if the height is 250 centimeters, is 21 years old. Did anybody get that right? Who did it? Thank you. Did you get it right? Did you get 12 right? He didn't do 12. He did it.
I didn't do no evens. While you were working on the evens, I was like looking at yours in front of me.
So the most you could have got was half anyway, because you were supposed to do all the evens I did for full credit. And you were supposed to do evens in class. When I say that, I look for it. And this was in class. I'm grading your classwork. Dang. I do. I look for evens. I said it out loud. I said it out loud several times. Listen to what you want back there. So distracted in your own freaking life. Yeah. All right. All right. And then I had a question about 18. I don't think we're gonna get to that. Who has a question about one of the odds that you did on your own?
Why are we not gonna get to 18?
I mean, I can.
I'm really questionable about that.
Okay. You did it. You really went enough. Let's do it. Okay. All right. I'm gonna raise both sides to a power of 3. You know what? A lot of people will not end up doing the 2 to the 3rd, and we didn't see this on many of these. So this would be 3 minus 8x squared is 8x to the 3rd. So be careful about this. The 2 also gets the power of 3. So, well, because you're doing the whole side, right? And all of our other ones, there wasn't a coefficient on x. So when I raise this whole side to a power of 3, that's 2 to the 3rd, x to the 3rd. So did you say you need me to come back here and talk to you? And then from there you set it equal to 0. Turn it back here. Oh, yeah. That's a really difficult one. From there, you'd have to do like long division. It doesn't factor. You'd have to do like polynomial long division. Yeah, let's just leave that one and move on to today's work. Sorry, Libby, I'll have to adjust that another.
Yeah, it's kind of impossible.
No, it isn't possible. Alright guys, let's take some more notes. So today's problems are extremely similar. The steps are very similar. The only difference is instead of a radical, you have a fraction exponent. So, all throughout this chapter, we've been changing from radicals to fraction exponents. So here, our first step is to isolate the base in the exponent. That's just like yesterday. You isolate the radical, so get it alone. What's new to you, and I've highlighted, is step 2. You raise both sides to the reciprocal of the exponent. So, for instance, if your exponent is 3/4, you're going to raise it to the 4/3. You flip it, and you do a power of a power. You'll then use some properties of exponents, solve and check. You'll have to use some quadratic skills, maybe factoring on some of them. And here's our assignment, same section 23 to 30. I'm going to give you guys some time to write this down. And then I'm going to start with number 24. I'll do 24 with you, and then 26. And you guys do odds on your own, and I'll go through some of these evens in the next 10 minutes or so.
That would be so funny though. A band.
I haven't heard of it, but I will be here on Monday.
That would be good.
Oh, this one? I'll be here on Friday or Monday, so tomorrow or Monday. Okay. It might be hard. I'll be in Mexico, so I might not be able to throw it. Visiting my family. Yeah. Thank you. I could just try to do it on the plane, but. What's that? I'm gonna do evens in class with you. No, you have to do the ones I do in class. You want me to jump to right to 30? Okay. Okay, my bad, my bad.
Honey, it's slow.
But Beatrice, if you want credit for that, you have to come after school. Okay? You're welcome. Um, if it doesn't start as a decimal, try to keep it approximate.
Well, apparently I'm not allowed to do that. Because I asked him, do you want me to go? He says, no.
Beatrice, here's what I'll do.
Okay.
I got something for you.
I'm just showing you.
Between now and the end of third quarter, I'll give you 4 opportunities to come up to the board and 4 extra credit points, and that's just like getting full credit on that assignment. Yeah? What's that? You're supposed to work with people. You're supposed to work with people. What's that? Yeah, whenever I say come to the board for extra credit, you always do it. So, and then if I forget, you just gotta be like, wait a minute, I still gotta do 2 more. All right, we're gonna go down to 30. I guess that's the most difficult one. And I'm gonna start with a 30. Okay. So here's our exponent. It's 1/4. The way to get rid of an exponent is to raise both sides to the reciprocal. All right. The base is already isolated because there's nothing before these parentheses or after. So I'll have to write this out myself so I have room. So what I'm gonna do is I'm gonna raise this side to 4/1 and this side to 4/1. And so 1/4 times 4/1 is 4/4 and cancels. So that's a really effective way of canceling a fraction exponent using its reciprocal. This will now be to the first power, which means it's totally canceled. So this is 5x squared minus 4 equals x to the 4th. Now this is a 4th degree polynomial. We're going to solve it just like it's a quadratic. We'll factor it like quadratic form. So I'm going to subtract these over here, make this side 0 so I can try factoring it. So I need to find out what will multiply to 4 and add to -5.
Literally, I never thought I'd see
-1 times -4. So because it's a 4th degree polynomial, in my parentheses, instead of just x, it'll be x squared. X squared minus 1 and x squared minus 4. So I hope that is looking familiar, and I do hope you do this on a separate piece of paper since there's not much space in here. Now I got to solve both of these. So I do x squared minus 1 equals 0, x squared minus 4 equals 0.
What is happening? What is that? X squared minus 1x, x squared. What is that?
These are parentheses.
Oh, the parentheses. Okay, that makes more sense.
And then so I'm going to add 1, add 4, add 4. X squared equals 1, x squared equals 4. Square root, square root.
Yay.
X is plus and minus 1. X is plus and minus 2. Now there's a good chance one of those don't work. Let me look. I don't think any of those negatives will work. All of these negatives are rejected. You can't have this be equal to a negative x. So my answers are just 1 and 2. Alright, now did you do 30? Because when I walked last time, I was looking for 30. Alright, now I'm going to go back up to 24 and do a shorter problem. This was the last problem, it's the longest, it's tricky, it's 4th degree. So now I'm going to go back and do 24. In 2 minutes. The main thing I want to show you is that this 4 is separate from the exponent. So I would divide by 4. So that's x3 over 2 equals 8. Raise both sides to the 2/3. And we get x equals 8 to the 2/3.
Got it.
But look, I'm going to put it as a radical and go even further. Cube root of 8 squared. 2 squared. Positive 2? I think you can. It's in the book. It's in the book. But I'll check it. What's it's a fourth root, isn't it? It's a fourth root. Look at check. I'm glad you checked it.